All right, cool. So today, let's talk about callback functions. And today's lecture should be relatively short too, which is great because you guys have more time to work on the workshops, and we can go over the solutions together if you want near the end of class. Okay, so callback functions are something that I think actually one of the prior workshops may have already exposed you to a little bit. But essentially, what it is oh, you can't see it. A callback function essentially is a function that takes in another function and just executes it for you, right? So in this case, if we start on top of the line 1 there, we have this function called overseer, right? And then in line 13, what we do is ignore the console log for now, that just prints things out, but we call overseer and we pass in two arguments. The first argument is a number, which we've seen quite often, but the second argument is this thing called add2, which if you look on line 5 is actually another function. Okay, and when we look at overseer to see what it does is we see that it takes in a number and it takes in another argument that's going to be a function. And what it does is it executes that function and then it executes this function with the number as the first input, and then it returns all of that for you. So if I was to go through here in line 13 and I would say, okay, what's the order in which things are happening? The first thing I know is I pass in a number, which is 10, and I pass in this function, which is add2. And then the next thing I do is I say, okay, it wants me to take this add2 function that's going to take in a number, right? And these two numbers are different, right? They just happen to be named the same thing, but they're fundamentally different numbers. And we say, oh, pass in this number into here, and just return that number plus 2. So when I run overseer 10 add2, I should get 12, because the first step is it takes this 10 and feeds it into add2, and add2 just takes this number and returns that value plus 2 more. And this returns, add2 returns this 12 to overseer, and then overseer returns this 12 to the console log, which is what gets logged out at the end. Does all that make sense in terms of the flow of how we did that?
Yeah,
Yes.
so just to, I mean, this might be kind of silly, but so in this particular instance, it needs to be a number. It couldn't be a string because you wouldn't, add2, you couldn't add a string to.
Yeah, so I'm trying to think what the coercion order is going to be. It might coerce one or the other, to be quite honest. We can try it. But essentially here, what you're asking about is right here, right? It's like, can we do like a string plus 2? Yeah, it's either going to throw an error for you or it's going to try to coerce it for you in some way together. But yeah, basically this could very well be a string if this is like, string plus another string, right? So really the most important thing here to realize is just that add2 is not being invoked on line 13. It's being invoked by overseer, wherever we call overseer, right? So if I say something like, and this is actually really good, this is a really good way for you to kind of get a function, pass in a number that you can save for later, and then call that function much later where you need to call it, right? So you can say, hey, I'm going to create this function here that I'm going to use for later on, and then when it really gets, and then, if 20 lines later in code, you say, oh, by the way, I want to call that thing that I had previously. Now you have like a preserved version of that function that you can call. Okay, so in line 14, very similar, right? Rather than add2, we now have this function on line 9 called multiply by 2, which operates in some ways very similar to add2 in that we're taking in a number as an argument, and we're just returning 2x that number. So when we call 10 and then multiply by 2, we're passing in num is going to be 10, and this operator flunk is going to be multiply by 2, and then right away what we're doing is we're calling multiply by 2, passing in this value of 10 in here. So now we're inside of here, and we're just returning back 20. Multiply by 2 returns that 20 over here, and then this overseer function returns that 20 to the console log, and that's why we have logged out 20 at the end here. Does that flow make sense for a lot of people? It's definitely something that we've seen before in some of the other workshop questions, but all this is saying is that there are certain expectations where it is very possible for you to pass in functions along with numbers, booleans, string, and objects as function arguments. Any questions at all about any of this? Everyone feels pretty good about this?
So the operation function that you have in the function oversee, and then the two parameters, the second parameter, which is operation function, it whatever like even if whatever function you have underneath that, whatever that function is titled is going to be put in that parameter, and that's how that's going to run first.
Are you asking? So this is going to equal to whatever is being passed into right here.
And then that's always going to be a function.
Well, so in this case, this is expecting a function, right?
Right.
So what will happen if I try to call over 0 is 10, 10?
It wouldn't work.
What kind of error would it throw? What kind of error would that throw if I try to pass in 10 or any two numbers into this over 0 function? Yeah, I think the error we see is like something like I'll probably say operator func is not a function, right? Because we're basically passing in, let's say, a number here. We're trying to invoke a number, and JavaScript says that's not invocable, right? There's no func, like I can't invoke that on something that's not a function, so it will throw that kind of error. So you can pass whatever you want inside of here. It'll just break by the time when you actually try to run it later on.
So in terms of just like talking about it,
yeah.
Which one is how do you use the word callback? Is it like operator function is calling back? Just the word callback is.
Yeah. So a callback is the same thing as a callback function. So those two are equivalent, and the callback function is a thing that is being passed in. So in this case, add 2 is a callback. Multiply by 2 is a callback. Usually, like colloquially, how people usually talk about it is they say, oh, just send that as a callback, right? Basically, this is going to be the callback that you give to another function for that other function to execute down the road. Yeah, so whatever's being passed in is the callback function. Cool. So why are we talking about callback functions today? It's because we're going to cover a bunch of, in this case, array methods, right? And so arrays are things that we've used very extensively so far in this bootcamp. And I think some of them, you may have seen these already. But arrays have a set of kind of built-in functions that you can also use that very easily allows you to iterate over the arrays, okay? One really important thing to know about all of these functions is that they're all optional. And what I mean by that is you can actually make do without, you could actually use arrays and use for loops to iterate over the arrays and do everything that you normally would using a for loop that you could with these functions, right? The reason why people use them is because one is because they're short and in often cases a lot easier to use, and the second reason why is because in some cases they abstract away some features that we'll talk about that makes it really convenient for you to iterate over the array, right? So for example, if I want to add up all the values in an array, if I was using a for loop, I could have this kind of global variable that's a counter and just keep incrementing that. The map function, for example, the reduce function, for example, has like a variable that's meant to be like something that's passed over for each iteration of the run. So we'll talk about that in a little bit. But the reason why these functions, why we're talking about these array functions in context of a callback is because all of them take a callback function, as in all of them expect to get a function that it will then execute on your behalf on every element in your list. So in that extent, it's operating very similar to a for loop, but once again, it does offer some more conveniences. So let's start with the first one, this for each. So for a for each loop, so the way that we use any of these what we call array prototype methods, and we call them the array prototype methods because these methods are available for all variables that are of the array class, right? So I think a lot of times when we instantiate a new array, we just do var arr equals, and we do like this, like the square brackets, and that creates this array for us. The other way to create arrays is also to instantiate a new array class, right? We can say var arr equals new capital A, which is what JavaScript used to denote classes, array, and we invoke that class, and that'll give us a new instance of it too. All of that is to say that all arrays, assuming they're arrays, has access to for each. It has access to all the variables that we saw on the previous page, and we'll cover all of them, one by one. So what does for each do? For each, when you do arr.for each, what it does is this is a method, right? or this is the function, right? And it takes basically in this case, this one just takes one callback for now, right? It takes in a callback, and the first thing that in the callback that it takes in is going to be a function. And you'll notice here that in this line 37, so basically the for each parentheses start on line 37, ends on line 39, right? In the middle is this function that we say takes in two things, something called val and something called end, and it in this case it just executes this on num times or equal val. So to unpack this a little bit more, what each one of these callback method does is it takes in a function, right? But it predefines what kind of arguments are going to be passed into these functions. As in, if I give for each a function, it'll say, great, you can give me any function you want, but I'm going to give it I'm going to give it a set of parameters that's going to be consistent, right? And in this case, the first argument that I will give any function you give me is going to be the value in that array. So in this case, when we do ARR equals 1, 2, 3, and we do that for each, this function is going to execute on the 1, on the 2, and on the 3, right? And so the first argument I'm going to give you is going to be the value of whatever element I'm operating on. So in this case, the val is going to be 1 the first time the for each loop runs. Okay, and the end is going to be the index of the element. So if I was to have a console log between lines 37 and 38, when the array.for each runs, I pass in this function. The first time it runs, val is going to be 1 and end is going to be 0. Okay, and what it's going to do is it's going to set num, which is up here, plus or equal to val. So it's going to be 1 multiplied by 1. Okay, I go to the next element here, which is going to be 2, right? For 2, I do the same exact thing, except now my val has changed to 2, and my index is now 1. And I set num equal to 1. It's still going to be 1, but now it's multiplied by 2. So now num is going to be 2. Okay, and then I move on to the next element in my array, which is 3. Now val is going to be 3, index is going to be 2, and I set num equal to num is going to be equal to num, which is 3 multiplied by 2, which we changed previously, and that's why console.log out num is going to give me 6. So what array.for each does is it goes through every element in your array, and it executes a function on it, passing into that function these arguments, which the first one's going to be the value of the array, and the second one's going to be the index of the array. Okay. Any questions on that before I talk about the last two bullets?
What's index doing with them? What's it doing?
Well, in this case, index isn't being used at all.
It's
But
not going to be used?
well, nowhere in the body of this function am I using it.
Yeah, so what's the use?
Well, I could very well have a use case for it in here, right? All I'm saying is I'm giving you a value, I'm giving you the index, and then you can do whatever you want with it inside of these functions, right? So this could very well have been num plus or equal val, and then num plus or equal index, too, right? Like, all we're saying is we're giving you these values that you could use if you want. So for these functions, actually, one thing you could also do is you could, in this case, just truncate it down to one thing. You would just say function val, right? And in that case, the array, the for each is still going to feed you the value of the element plus the index of the element. But because the first one it feeds you is going to be the value, and because your function is set up to only take one argument, you will get only the value. So in this case, if we had truncated this and gotten rid of this second argument, this function would still work, right? Because we're not using index anywhere.
When you use for each on an array, does it always give you the value and the index in the function? Or?
Yes, for each, yes. Yeah, so this is why the concept of a callback is super important, right? Is that for each says, I expect you to give me a function of your choice to execute, but I'm always going to give you these arguments, right? So this function inside here could be anything, but the first argument that I give you is always going to be the value, and the second argument I give you is always going to be the index.
So we can call that function whatever we want.
You can call it whatever you want, yeah.
And
in this case, we actually
define
created
the function in between the curly braces however we want.
Right. So in this case, we actually define what we call a anonymous function, right? Like there's
Yeah.
no name associated with it. In line 36, I could definitely have say like var foo equals a function that takes in 2 random arguments and does the same thing, and I could pass that into here as well. And we'll see that in one of the later slides as an example for how you can pass variables into here as well. But the key thing to note is just that for each is expecting a function as the argument, and it's going to give that argument a certain set of for each is expecting a function as its argument, and it's going to give that function these set values, which is going to be the value of the element and the index of the element.
So you don't literally have to pass it those values or those. It's just preordained.
Right. For each is going to say no matter what you give me, I'm going to give you the value in the index. You could choose to only take one of them if you want, but these are the only things I'm going to give you. In fact, I can't give you anything else.
And if it only has one argument, then it just gives you the value.
Right. So how arguments actually work in JavaScript is that it comes in the form of an array. So the order of the arguments matter quite a bit. So in this case, what array.forEach does is gives you the value, it gives you the index, and I think the third argument is an optional one that could also be the whole array itself. That one we can actually Google to see what the argument for it is. But just know that that's consistent across the board. Like for each is always going to give you value, index, and then possibly the array as well.
If we use for each when we want to add the elements of the array, okay, that's the only purpose.
No, let's say I have an array, but I want to decrement every number by 5. I want to decrease every number by 5. Right? This basically for each allows me to do a function on every single element in the array. I could absolutely duplicate this with a for loop if I wanted to, but this is just like a shorthand for writing it. And the more convenient thing about it is that it kind of gives us these values baked in, right? It says you don't need to explicitly set a counter to keep track of the index, and you don't need to get the value by saying ARR index. I'm giving you the value and I'm giving you the index already. So this is a for each loop, okay? For each is a little bit unlike all the other methods, and we'll cover the other ones later on. But the two things that makes it special are, one is what for each really is great for is for doing something to the actual element. It doesn't return anything, rather it returns undefined. So you can't say return array.forEach because it returns nothing, right? All of this actually does is it's primarily used for either mutating the values or for, in this case, modifying another variable with it. So array.forEach returns undefined. Just remember that. This is used primarily for doing something with your existing array. It does not create or return a new array. So that's the first thing. The second thing is that it's not chainable, and what that means is that I can do array.forEach something else. Whereas all the other array prototype methods are chainable, so you can run several of them concurrently, right? And the reason for that is because all the other array functions are going to return something, right? So you can do more functions on whatever is returned. In this case, for the for each function, because the for each doesn't return anything, you can't chain it with anything else because undefined has no methods on it.
So before you move forward, can you quickly walk me through how you got 6 again? You kind of went through how about.
Sure. So we have var num equals 1, right? That's kind of like our parent variable. And then we have this list here of 1, 2, and 3.
Yeah.
Okay? And I'm calling this function inside of here on this array, right? So on the first time it runs, it says, okay, give me your first element, which is going to be 1,
Yeah.
right? So val is going to be 1, and index is going to be 0.
Okay.
And what I'm going to do is I'm going to say number equals number multiplied by val, which is going to be 1, right? 1 equals 1 multiplied by 1.
Oh, okay.
Cool?
Yeah.
So that's the first iteration for this 1 value. I then move on to the 2, and now val is going to be 2 and index is going to be 1. But num, which is still 1 after my previous iteration, now that's going to equal to itself multiplied by the new val, which is 2. And now num is going to be 2.
Yeah.
Okay? And then I move on to the third element, which the val is going to be 3, the index is going to be 2, and now num is going to equal to 2 multiplied by 3, which is 6. right? And so here, when I'm console logging out num, is by the time that this function runs, by the end of it, num has been changed now to 6.
Oh, okay, because it run through the whole thing.
Right.
So that's what you were talking
yep.
about. So when you say you can change the value of each index, I was just thinking you would change, like if you want to increment it by 5, I was thinking increment each one in the array.
Well, you totally could do that, but we can't. We're just,
Not with that one though. Not with that one. That right there isn't going to do that. That's
no, this is doing something completely different.
right. Okay, that's what I was confused about.
Okay. Yes.
So for this for each method, the index is incrementing because the index is incrementing because behind the scenes there's an automatic plus thing happening.
Yeah.
That's basically what the function is doing.
Yep. Yeah. For each executed from left to right in order.
Right. That's why your index is here.
Right. Yeah. The only thing that I think it does a little bit that's a little bit tricky is, and this is something that you guys can definitely test out when you on your side too, is I believe what for each does is, so normally when you make an array, right, you have like an initial array and then you kind of add values or take away values from it, but it's almost like every slot has a value. With the arrays, the other thing you can also do is you could just say, here I have an array of lengths 3, right? I also say, hey, the 10th element in this array is going to be a 0, right? And it will create a 0 for me, but everything in the middle, like indexes 4, 5, 6, 7, 8, and 9, will all be blank. And I think the for each will actually skip those blank elements. But that's like a more of an edge case that you guys can kind of play around with on your. You guys can play with probably during the workshops more. But for now, just take it that as long as your array is continuous, it will go through it in order from left to right. Cool. So here's another array prototype method called filter. Cool. Oops, sorry. Okay. So what filter does is filter loops over the array, just like the for each does. It takes a callback, and this callback is actually fed 2 arguments as well, which is going to be the value of the element and the index. Okay. And by the way, like these are the kind of things where, like, even when I use these, like at work, I still Google them just to make sure, like, I remember what the arguments are, right? Because, like, programming, it's not really about memorization, quite frankly, because almost everything that a programmer needs is online somewhere, and someone writes it down for you. So you just look it up for reference, right? So don't get too hung up on memorizing exactly what the arguments are, but really try to understand kind of what this is doing conceptually, because in almost any other scenario in which you would actually need to use it, it's very easy for you to Google, array filter arguments. Like, there are vast number of resources that tell you exactly what goes into the what the set arguments are for these. Cool. So in this case, what filter does is it goes through this array just like for each does. It takes in a callback just like for each did. It has a value and has an index just like for each did. So everything on line 3 and line 5 are identical to what we saw with for each. The only difference is filter actually does return something, and what it returns is a Boolean. It's going to try to evaluate whatever you give it, and it's going to try to coerce it into a Boolean. And the purpose of filter, as the name implies, is it decides whether or not to keep an object or to keep an element in the array. Okay. So this use case that we have up here, right? We have an array. It's kind of small, you can't see it, but trust me, they're just like numbers, and they go from 1 through 9. But we have a few duplicates in here, right? We have an extra 1, we have an extra 2. I think that's it. Yeah, so we have a few extra and an extra 9. So we have a few numbers in there that are duplicates. And what we're trying to say is, hey, can you filter out all the duplicate values for me in this array? Well, how can we do it normally? Without this filter method, we could very well write a for loop, right? Where for each number, we look through the rest of the array and see if it's there. If it is, we take it out. If it's not, we keep it, right? So that's doable without using a for loop. Filter gives us a much more handier way to do that, in that this function is going to return a Boolean. It's going to coerce or we give it into a Boolean, and that Boolean, if it's true, means we keep that element. If it's false, it means we toss that element away. Okay? And so what this one is doing is saying, okay, I have my value here, right? tell me, is the index of this value in my array equal to my current index? Okay. What this is going to do is, this is going to say, okay, let's say I start with the value 1, right? That's my first value. Okay, is the index of 1 in this array, is that going to be 0? Because, sorry, this is going to be 0 for the first time I see it, and then it's going to equal to the index, which is also 0, right? So this checks out. So I'm going to keep this first value here, right? By the time I make it to the fourth number here, which is also a 1, the value is going to be 1 still, but now the index is going to be 3, right? Because this is the fourth element. And it's going to say, okay, great. What's the index of 1 in this array? And it's still going to give me this first one, which is 0. And I'm going to say, oh, this is not equal to the current index I'm at. This must be a duplicate. Let's return false. So I don't keep that number. And it'll do this for every single number in this array. So it's basically going to check to see, does this array have a number 1? And then if it does, is the index of that number equal to the index of what I'm currently looking at? Because if it's not, it must be a duplicate. And so by being able to return either true or false on every element in this array, what array.filter does that's very different though for each did is this is now going to return a whole new array. And in this array are only all the values that had passed true. So when we console log out the original array, we'll see that it wasn't changed, right? There are still duplicates in the array. But when we look at the new filtered array, we'll notice that all the duplicates have been filtered out, and now we've only kept the ones that are unique.
So it's not going to alter the original one?
No, for each will alter the original. Well, for each will alter the original array. The array.filter and the next two ones that reduce in the maps are all going to return a new array. Okay, so in this case, and so because this returns a new array, what it does is now if I want to filter it again, right? Say, hey, can you also take out all the even numbers as well? I can just write another dot filter at the end of this, pass another callback function, and keep going. And the reason why I am able to chain them together like that is because this one does return an array that I can then do more array prototype methods on.
So the filter function returns an array.
Yes.
Okay.
And you can do that with strings or anything. If there was like multiple, like if you had like a list of dogs, cats, and all these different animals, you could filter it and get the duplicate dogs out or the duplicate cats out. Or does it only work for numbers?
No, it works for all. It works for any data type that you can compare.
Oh.
Yeah. And so down here is just a really quick example of what we talked about earlier, right? Where here we have an anonymous function that we're passing in. We could also very well declare this function like outside of this and say, hey, we have a no double space function that takes in 2 arguments, does the same exact thing as up here, and now we just pass it into filter. And filter will basically, once again, same as up here. So these two are identical. It's going to call this function, and it's going to pass to it the value and the index. So this is just another way for us to do this as well. That in some ways is a little bit cleaner, right? Because this is pretty clear on exactly what it does, and it decouples everything, whereas this kind of puts everything together. So once again, filter, as the name indicates, all it does is returns, it evaluates everything into a Boolean, and that Boolean will tell you whether or not it keeps this element in the new array. That's the main use case of filter. Any questions?
So for value and index, we don't have to assign those parameters. Those are just, it's just going to look for 1 and then go look for 2s and then for 3s. Is that
1s, 2s, and 3s.
So so when you were going through this like step by step, you said, okay, so value is 1 and then we're going to, for once we get to 0, 1, 2, the third index, well, they don't, since they don't equal one another because it thinks that it's still 0. Can you just walk through that again and just explain, because I don't understand how you're going through it.
Sure. So what array.filter does, right? It takes this callback function.
Okay.
So this callback function here, right?
Okay.
And it executes it on every single number in this array. Okay.
But we don't have to put anything in that function. We don't have to give it parameters. It just knows that it's going to do that.
Well, we define the parameters up here because we know what to do with it.
Oh, so the parameters are just going to be val and int each time.
Well, so in this case, because we're passing it into here, right? We need to tell this function what to expect. This is gonna filter is gonna invoke this function with the arguments of the value and the index, right? So we could call these variables whatever you want, right? These could be any names, right? But the first thing that filter is gonna pass into no doubles please is gonna be the value. And the next thing that it's gonna pass into no doubles please with is gonna be the index. So when no doubles please gets run on 1, filter is going to say, okay, I'm going to pass you 2 arguments. The first one's going to be 1, and the second argument is going to be 0 because you have a value 1 and an index of 0, right? Do what you got to do. Return a Boolean, and then you take care of it from there, right? It's going to do this on 2. It's going to do this on 3, and then when it gets to this 4th element, which is another 1, it's going to do this exact same. It's going to do this exact same thing, except the val is going to be 1 still, but the index is going to be what? 3, right? And so this is going to be 3, right? So it wants to check, okay, is the first time I see a 1 in this array at index 3? And the answer is going to be no, because the first time I see it from left to right is going to be at index 0. So clearly I have an inequality here, so this is going to be false. And if I return a false to a filter takes out to mean, okay, you don't want this value in the new array that I'm giving back to you, right? And so it does this over the entire list. And once you go through everything, it just means that every number, the first time that you see it, is going to be at that. It's going to be at the index, and we never see a number again anywhere else. And so that's why we say this is going to break it down into the filter of uniques.
Okay.
Is everyone feeling good about filters? Filters are a bit tricky to use because they return. I guess the Boolean returning part is a little bit like conceptual. Hopefully maps will be a little bit more straightforward.
So on filter, you can only do it from the beginning. You can't do it from the back. Like, you could pause.
Yeah, filters.
Shift.
I think all array prototype methods it executes from the left to the right. I don't think there's a way to execute it in a different order.
So if you wanted to filter something and say you're like, okay, so I want to filter a list and I want to keep the duplicates towards the end of the list, but everything at the beginning of the list, I want it to, if they had it before the beginning, I want to get rid of it. You couldn't do it that way.
You could just reverse the array first and then do this, and then reverse it back.
That's how you do it.
Yes.
So the callback function gives back a boolean.
Yeah.
And then that accepts the. Because I was just getting confused. You said it returns a boolean, but the callback function returns a boolean, and then that filter method accepts a boolean, and then it's like yes or no.
Right. Exactly. Right. The callback's going to return a boolean. That filter's going to use that to decide whether or not to keep this element in the new array or not. Yes.
These methods don't work for nested arrays.
Well, so it depends on what you mean by nested arrays, right? So let's just say this first element with a nested array of 1, 2, 3 in of itself. If I step through this, val is going to be a nested array of 1, 2, 3, right? That's going to be the value of the index. So what that means is now we're looking for another nested value of 1, 2, 3 in the array. And so in that way, if that's what you're checking for, it does work. Right? If instead what you're asking is, can you check to see if this number is also in any of my nested arrays, then the current implementation we have here would not work. Right? So we could make it work, but the way we currently have it constructed would not. Cool. Everyone feeling good about filters? Booleans? You'll get to. This is the kind of thing where I think really just there's no replacement for practice in terms of just kind of using them. After you use them a few times, you'll get a hang of kind of how they work and what they're doing. Okay, JavaScript also gives you a sorting function, which is a little bit tricky because the way JavaScript sorts is okay. So let me phrase it this way: you should sort mostly numbers. Like if it has strings or like strings of numbers, I wouldn't sort them because of the way JavaScript like assigns values to strings, right? So what's an example here? Like for example, in JavaScript, 10 is theoretically less than 2 because the first character is a 1 rather than 2. So when you try to do strings and other things, it gets a little bit wonky. So my rule of advice is usually when I sort this is I only try to sort numbers, and if it's not a number, I try to convert it to a number first before I sort it, just to kind of keep it very consistent so I know what's going on. Okay, the sorting function, it takes a callback like everything else we've seen so far, right? And that callback is going to get 2 values as well. And what it gets is the argument is the value of the index that we're at, and the next element that's coming up. Okay, so for example, if I try to sort this at 3, 2, 1, assuming the array is 3, 2, 1, when I sort it, my initial value is going to be A is going to be 3 in this case, and then B is going to be 2. Okay, and what this does is this callback is going to give you back a number. Okay, and if the number is a positive number, then that's an indication to the sort function that it's going to switch those 2 numbers around. If the number is a negative number, then it's negative or 0. I think it will basically keep the order as it is and move on to the next element. So conceptually, if you think about how this actually works when we try to sort it, on the left-hand side at least, what this is doing is saying, okay, I'm giving you an array of 3, 2, 1, right? I'm going to look at the 3, and I'm going to look at the 2, okay? 3 minus 2, does that give me a positive number back? Yes, it does. So I need to change the 2 and the 3, okay? Now, I'm going to start over again because I changed these 2 numbers. I need to make sure that I get to a point in which there's no basically, this function ends is when it goes through the whole array, and it doesn't need to change any other number. That's how it knows that it's done, right? So after the first run through, I'm at 2, 3, and 1, right? And then I'm gonna run this again. 2 minus 3, that give me a negative 1, right? So I don't need to move it. Cool. Next number. 3 and 1. Does that give me a positive number? It does. So I need to change those 2 now. So now I'm at 2, 1, 3. I start from the beginning. 2 and 1. 2 minus 1. Does that give me a positive number? Yes. That means I need to switch those 2. So now I'm at 1, 2, 3. And then on this last run through, when I go through it, it's gonna say, okay, 1 minus 2. Did that give me a negative number? Yes. So I keep those. Next 2. 2 minus 3. Did that give me a negative number? Yes. So I keep that. And then because I've reached the end of my array and I haven't had to do a single switch during that run through, I know that this array is properly sorted.
So A and B are the number and the next number.
Exactly.
Okay.
Yeah. So sort just basically like think of it, you have like a window of 2 numbers, and you just keep shifting it from left to right. And anytime you need to switch, you go back to the beginning and try doing. Anytime you need to switch, you switch those 2 numbers, then you move that window back to the beginning and try going through it one more time again.
The very beginning.
The very beginning, right? Because like the danger is like you might switch these 2, but that number you switch might be the smallest number in the whole. So you need to somehow move it back to the very beginning. And this sort function knows that it's done once it reaches once it goes through the entire thing without having to rearrange any of the numbers.
So sort is another way to reverse an array of numbers.
Potentially, yes. Well, sorry. Sort can be used to. It only works if your original list is sorted. Right? Like if I have a number that's just like if I listed like 1, 7, 28, negative 2, and 0. If I sort it, it's going to need to have like a sorting criteria, right? I can't just reverse it arbitrarily. If that makes sense. Right? So if my number is 1, 2, 3, 4, and I want to reverse it, I can sort it weirdly. Right? But if I want to keep the same order but just reverse it, that requires something different. Okay. So sorting is very methodical, right? You need to have a specified way to tell JavaScript how you want to sort it. This is by far the most common, and I almost want to say that by default, if you don't pass anything in, that's what it does. But obviously, if we want to sort it from biggest to smallest, right? It's a very simple change. We just got to switch these 2 numbers around. right? And then that will preserve the order of going from biggest to smallest as opposed to smallest to biggest. Okay. Sorry. Okay, cool. So on this right-hand side, then what we're doing here is we're doing the same exact thing, except one thing that you also notice about this sorting function, right, is what it does is it's actually mutating the original array, right? In this case, we're not saying ARR equals ARR.sort. ARR.sort is not giving us back a new array. It's taking the existing array and just shifting everything that's in the array, and so the original thing gets changed. If what we want to do is we want to say, hey, can you give me a copy of this array that's sorted, but don't mess with my original array? Then what we got to do is we got to return back to our old friend slice, which once again creates a copy of the array, and then we sort that. And by sorting the copy of it, the new array is now sorted, but we don't modify the existing array because once again, array.slice returns a copy of the array, right? Like this is a great example of how we chain together functions, right? Is we have an array, we're copying it, this returns a new array, and on a new array, we do the dot sort.
So if we didn't have the dot slice there, we would still be changing the original array.
Exactly,
Okay.
exactly. Yeah, in that case, then what we would be doing is, oh, actually that's a good point. If I don't have the dot slice here, what do you guys think is going to happen, or what do you think the value of the new array is going to be? I have a guess, but I'm going to check it. So what's going to happen on the right-hand side if line 72, if we took out the dot slice and we just did ARR, var new ARR equals ARR dot sort? Any other guesses besides 1, 2, 3? Okay, so what you're saying is basically creates a reference to ARR. Okay, cool. So, it will concat it with ARR.
No, to the references the content.
The content of the text. Okay, cool. So what we have here is, so we have new ARR, and then down here we have a console.log new ARR, right? So originally what we had was we had ARR.slice, and then we're sorting it, and let's just try this. Okay, cool. So what this does, so by not passing the function, it does kind of the default what we just saw. So my question now is what happens if we take out the dot slice? Well, in this case, we're sorting it from, what was the original function we saw? Oh, shoot. Sorry, guys.
We are recording, right?
Yeah.
Okay.
You usually get all of these. Cool. So in this case, what we have is, oh, AR321, my bad. Cool. So this is what we had originally, right? So this is what we just saw on the slide. And my question is, well, I guess you guys, yeah. Cool. Cool. So in this case, it looks like what it's doing is it is returning back the new array as well. It's going to return back the reference. So actually, let's try this now. So now if we do ARR.push 4, this will tell us very clearly if it's going to be giving us a reference to the original array or if we're doing this on copy the old array now. Cool. So we are creating a reference to the other version of ARR. Does everyone understand what we just kind of demonstrated here? Right, what we're saying is here in this slide here, originally what we were saying is originally we were sorting the original array, but now by taking out the dot slice, we're now just creating a reference of new ARR to this variable. And if we ever change ARR, new ARR is going to be changed as well.
So you just, to get it sorted the opposite direction, you switch A and B?
Yep.
And it's sensitive to A and B?
Right, and the reason why it's sensitive to A and B is because really, really, if you think about how the dot sort works behind the scenes, is like it's expecting the callback to give it a number, right? and it's going to say, if this number is greater than 0, I'm going to switch you. Otherwise, I'm going to leave you 2 in your original places. That's all it's doing, right? So by switching these two now, what if a number would have been positive before, so we would have switched it, now we're keeping it the same. And before, if it had been smaller to larger, it would have kept in place. Now we're switching it. So that's why that's right. We could also very well just multiply this by -1 if you want to. Completely up to you. There's a bunch of ways to do it. And once again, because of the number thing, please only sort numbers. Strings are really messy, and strings of numbers are just like ungodly, like difficult. Good. What if? Oh, okay, I guess you're gonna sort strings here. Cool. Or actually, no, those could be numbers too. Anyway, so what if I want to sort an array of objects, right? And assuming this object had certain values in it. Well, the other thing I could also do is I could be very, very explicit about how I want this to be sorted, right? Remember, A and B are just the values of the first two things in the array, right? And if I have an array of numbers, then A and B are just numbers, right? If I have an array of objects, then A and B are just objects. And based on what Sean covered on Monday, you can then just access any field on that object like you would normally, right? Because once again, A and B are just values, like they are just those objects, right? So you can access it however you want. And so here, what we're actually doing is we're being very, very, very explicit about how I want to sort it, right? And that we're not even just gonna have this function do math and give it a number. What we're doing is we're explicitly telling it to return a number, right? 1 or -1. So let's say I have a list of like 20 numbers, right? And I say, I don't care about the order of the rest of the numbers, but I want to move all of the ones to the very front, right? How would I do that? Well, under this paradigm, one thing I could do is I could say, hey, if val is equal to 1 and the next number is not a 1, let's just return +1 so that those numbers are going to get switched. And by doing that, you can almost shift any number you want to the very front, right? So once again, what I'm trying to say here is that this return value is super important, right? Because whatever you return here, this essentially tells the sort function. Sorry, it basically tells the sort method here whether or not you should be switching the numbers. So you could have it do normal math, or you could just be very explicit about how you want it to be sorted. So this is why you can customize your own sorting algorithm however you want. You just need to make sure that it returns a number at some point.
And those numbers are generally 1 or -1.
Right, that's non-negotiable in that the sort function is going to take a look at your number. If it's greater than 0, it's going to switch it. If not, it's going to keep it the same. That part's not negotiable. But you could obviously say, hey, if A is less than whatever, return 1, right? So that part, like this if statement, it doesn't care about at all. All it cares about is what gets returned. Cool. Everyone feeling good about sorting? Makes sense, kind of? Awesome. Okay, 2 more, and then we're done. .map. So map is something very similar to for each, except what it does is, whereas for each, it doesn't return anything, right? It just does something on each element, then it moves on to the next one, and so on and so on, and in the end, it returns undefined. What a map does is it's almost identical to that, except you return a value, right? And this value is what ends up being captured in the new array. So map does return a new array. Okay, so map returns a new array, and whatever value you return is what gets populated into that new array. So here what we're saying is, hey, for this numbers of 1, 2, and 3, why don't we return back a number that's equal to the value plus the index, right? If we do .map, it's going to execute this function on 1 index of 0, and that's going to give us 1 down here, right? And then it's going to execute on the second number, is going to be value of 2 plus an index of 1. So 2 plus 1 is going to give us 3. And then lastly, it can operate on value of 3 and an index of 2, which is going to give us 5. And once again, this is going to return back a whole new array. So when we print out ARR does not change at all, but new ARR is now equal to whatever what new array gets returned from the map function.
So that's really just returning the odd numbers in this array. Like if it went on to 100, it would just give you all the odd numbers.
It would give us odd numbers, assuming these 0, 1, 2, 3. It would, because the index and these numbers can be off by 1 always,
Yeah.
but these numbers could be anything.
Yeah, exactly.
Right.
In this particular way, if this array continued to 100.
Sure. Yeah. So in this case, this one would be giving us all odd numbers. Yeah. So map just returns a new function, and whatever value returned gets populated in a new function. This is a one that honestly I see get used more than anything else, because it's a very common practice to say, oh, here's an array, I want to do something to it, and give me back a new array with the modified values. This is the best one, right? For each, some people usually don't like changing the original array because you're just basically creating ways for you to not be able to undo what you just did. So people don't like that. And this one really just is like the most clear-cut way of just saying, hey, take this array, return the current number plus 5, and now I'm gonna get back a whole new array with everything incremented by 5. And there's no link between this array and the previous array. And then finally, reduce. Okay, so reduce is the one that's probably the trickiest. What reduce does is it actually goes through, and I think the best way to describe this is talking about like what's like a use case for reduce, right? Reduce is what we would use if I said, hey, can you sum up all the numbers in a array for me? Okay, and so reduce also takes a callback. What it returns is usually what it returns is whatever you tell it to return. In this case, is because we're trying to find the sum of all the numbers in the array, it's going to give us back a number. Okay. So all the other functions, all the other array methods, if you notice, it takes in a callback as the sole argument that we've seen so far, right? Reduce actually takes in two things. It takes in a callback as the first argument, and it also has this second argument here. And what this second argument here is basically, how do you want me to store all the values that we're seeing here or that we're going through, right? So reduce when it passes to the callback is it automatically goes to the it skips the first element, but it starts with the second element, right? And it says, what is the second element and what is the element right before it? And based on those two criteria, I'm going to do something, and also has the index as well. And so what this is going to say is, so if I was to iterate this over this array, right? Just bear with me here. Reduce is really tricky to explain, I guess verbally without seeing it kind of go through the code. But essentially, if I have this array of 1, 2, 3, and I do a reduce on it, and I pass it this callback, what it's going to do is that it's actually going to start. It's going to instantiate for all intents and purposes, we can say that actually starts at the current, and previous is going to be whatever we pass in here, right? So when we start on the first iteration, we're starting on 1, right? It's going to say, okay, I'm at the first element in this array, and there's no previous, right? There's nothing before it. So so where am I starting off? What's my default value? My default value is going to be whatever the second argument is here, okay? And I'm going to return that argument plus my current one. So after I go through this for 1, previous, whatever number I return from this function is going to be the previous for the next element, right? So when I start at 1, my previous is 0, right? And I return 0 plus 1, which is 1. So when I move to the 2, the current is going to be 2, but my previous is now 1, because that's what I returned from the last function call, right? And so I'm going to return 1 plus 2, which is going to give me 3, okay? When I move on to the 3, 3 is now my current, and my previous is now what? 3, because 3 is what I returned from my previous function call. And so I add those two up, I've reached the end of my function, and that's what's the number that gets returned, which is 6. So the reason why reduce is really convenient in some cases is because it has this thing called a previous and a second argument for instantiating it that really says, hey, whatever you want to do, here's like this global variable. I hate using that word, but here's this global variable that you can use to keep track of the things that you see. Okay, so this function allows you to add up all these numbers. The reason why I say that the reduce may not always return a number is for whatever reason, if you say, hey, I want to create a clone of this array, right? This could very well be an empty array that we start off with, right? And for each one of them, we can say return previous dot push the current value. And if I go through that the entire array, what I basically have at the end of this reduce is an array that's the exact copy of my current array. Right? Because assuming we're doing previous dot push current, and this is an empty array, when I start at 1, it's going to say, okay, empty array, push in 1 and return that. So now my previous is going to be an array of 1. I'm going to move to 2, and it's going to say, okay, previous array, push 2 into there and return it. So now I have an array of 1, 2. I move on to the 3, it's going to say previous array, push in 3. So now I have an array of 1, 2, 3, and then I return that at the very end of my function. So think of previous as just a way for you to kind of have this vessel that you can use to store and keep track of things as you go through your array. Does that at least make a little bit of sense to everyone? Once you start using it, it will become a lot more clear. I promise I'm not just saying that. Like, these are things that, like, when you look at it conceptually at a high level, it kind of makes sense. When you first start using it, nothing's going to make sense. But you use it enough, it will start making sense again, I promise. Okay. But reduce, basically, like the feature of reduce is just that here's another way for you to keep track of things that you've already seen. Yep, and so this is an example where they're doing the same thing, except rather than having an array keep track of things, we're actually just creating an empty object, and we're saying for everything that we see, let's put it into an object, right? So we have an empty array, and we're saying, hey, whatever your current value is, we'll make that a key, and then the value is going to be that word capitalized, essentially, is what this is doing, essentially. Right, so cat is going to equal to capitalized cat, mouse is equal to capitalized mouse, and fish is equal to capitalized fish. Right, so this is another way for us to iterate over the array and use a different data type and try to change data forms in another method. Yes. And the last thing is just that, well, you can see it here, but last thing is that because some of these return arrays, you actually are able to chain these together, right? Because for the ones that do return an array, you can then do something else with it as well. So really quickly, I'm just going back to this really early slide here where we were talking about all of these, and we'll go through kind of like the specialties of each one, right? The for each, what this does is it goes through the list and does something to every element. It does not return a new array, and you can't chain it. Okay. Filter. This basically expects the callback to give it a boolean, and it will use that boolean to determine whether or not it will keep the value in this new array that it's producing. Sort. It expects a number from the callback, and if the number is greater than 0, then it will switch the numbers. Otherwise, it will keep those two elements in the same order. If the number is greater than 0, it will switch those elements. Otherwise, it will keep the elements in the same order. Map. It will basically create an array of whatever value you pass back to it. And then reduce. It will go through the entire array and have this container that you can use to keep track of the things that you see as you go through the array, depending on what the criteria that you want to set it is, right? So for something like reduce, if I say, hey, I only want to add up all the even numbers in this array, it's very simple, right? You can use the same reduce function that we've seen, but you just have an if statement saying if this number is even, add it to the reduce, otherwise just return the previous value. Sorry, if this number is even, add it to the previous value and return it, otherwise just return the previous value.
Which would be sort of, instead of using the modulus, is this,
well, you would still use a modulus to do like the if part of the statement. But now, because rather than just returning the previous plus the current number, you now have an if check to see when you want to add the current number to the previous number. Okay. Any overarching high-level questions on the array prototype methods? Okay, good. Long enough. All right, awesome. I'll open the workshops. I'll Slack out pairs. Feel free to take a break, and then we'll probably start going through the questions maybe around like 9:15 ish.